So welcome to the first series of data manipulation using pandas. In this session we will be dealing only with merging. So let's first understand what is data manipulation. See, before you start manipulating any data, it's very important that you prepare the data, you assemble them in a form of a data structure so that it can be manipulated later with the tools which are made available by the pandas library. Now, there are different procedures for data preparation like loading, assembling, merging, concatenating, combining, reshaping or pivoting and removing. So in this presentation, we will be exploring the three phases of, in this entire series of data manipulation, we will be seeing three phases of data manipulation: data preparation, data transformation and data aggregation. Now, the data which is contained in the pandas objects can be assembled together in different ways, right? So we can do assemble these data objects in different ways, and three main techniques are merging, concatenating and combining. Today's session we are dealing only with merging. So to perform merging, you have to call the pandas function .merge function. This will basically connect the rows in a data frame based on one or more keys. If you're doing concatenating, you have to call the pandas.concat function, which will concatenate the objects along an axis. If you're doing combine, then you have to call the combine_first function, which basically allows you to connect the overlap data in order to filling the missing values in a data structure by taking the data from another structure. So today's session we will see just merging. So what is merging? See, merging operation is very similar to the join operation in a SQL. So in SQL, normally we call the join query, right, to combine the two tables, let's say, using some reference values which we call it as keys. And we finally obtain a new data which is in a tabulated form, basically which happened because of the combination of these tables. The same operation now is available in library pandas, which we call it as merging operation, and the merge is a function which is doing this merging operation, right? So when you're calling the merge function, there are a lot of optional arguments that it has, but we will be dealing only with these three optional arguments in this session: how, on and left on, right on. So if you specify the optional argument how, basically this is to tell what kind of merging I want to make, right? Whether I want to do inner merging, outer merging, left merging or right merging, right? Suppose you don't specify the type of how, then it will be defaulted to inner merging. Suppose I'm using the on argument. So this is basically going to tell upon which column or which index of the data frame I want to do the merging, right? If you don't specify this, then left index and right index will be taken as false. And there's one more, left on and right on. This will specify the column or the index that's present only in the left or right object that you are merging. By default it will be none. Okay, so this is a visual representation of what I just told you. These are the four different types of forms we will be seeing in the Python program next: inner, outer, left, right. So the blue represents the data frame 1. In all our examples, we are trying to use data manipulation on the data frames only. So data frame 1 is the blue one and data frame 2 is the red one. So if you are doing inner join, so that means the intersection of these two would be the inner join. If I am doing left outer join, that means complete data frame 1 and a part of data frame 2 which is a common value with data frame 1 would be the result. If suppose I am doing right outer join, then the output would be the complete data frame 2 plus the common points of data frame 1 and data frame 2. So this is the same diagram. So this diagram represents the inner join. This diagram represents the left outer join, this diagram represents the right outer join, and this diagram represents the full outer join. Okay, so we will also see something called as merging on index. So these cases which I just told now, they're all done merging based upon the columns in a data frame. Now I can, instead of doing merging based on the columns, I can do merging based upon the index. So then we call it as merging on index. So if you want to do merging based on the index, you have to use two more options: left index and right index. You have to make it true. Okay, so let's see this example first. Suppose I have created a data frame A like this, and this is the data frame B. right? Data frame A has, this is the column and these are the indexes. Fine. The column of data frame A is ID and val1. The indexes are 0, 1, 2, 3. Similarly, I have columns similar name ID val1 in data frame B and similar index. Let's first see how the function to do merging. pd.merge, you give the first two arguments as the name of the data frames. Now suppose I just give on is equal to ID. I don't give anything else. So that means what? I will be merging the data frame A and B based upon the key value, which is ID. So the key value is ID. If I give how? If I give it as left, so that means I am doing merging based upon the left merging. That means I will have all the elements of data frame A plus the common elements of data frame A and B. If I do merging using right, so that means I will have all the elements of the data frame B plus the common elements of A and B. If I do merging based upon the outer, so that means I will have all the elements of A and B. See, if you see the table, you can well understand this. If I say how is equal to left, see the merging is based upon ID. So that's why the ID here, right, I will be taking the ID of A only because I am using the how merging as left. So that means all the elements of A will be here. Right? So the complete ID of A is over here, complete values of A is over here. The only difference is now it's called as val1 underscore x. Now for y, val1 underscore y it will take, and only the common elements are there. See, the common ID between these two data frames is only 1 and 2. So that's why PQ is represented here, and 9, 8 is not common. So in that case, it is automatically giving the value as NaN. That means not assigned. Okay, now suppose I do the merging on the right. The entire data frame B should be present in the output and only the common elements of this data frame A should be there. So you can see complete 1298 is here and complete PQRS is over here. And when you come to val1 underscore x, only AB is here, the rest two are NaN. If you are doing merging on right, you can see that both the data frames A and B should be completely there in our output. Right? So you see 1 to 10, 12, A, B, C, D. So this is a complete data frame A. And in 1, 2, I had PQ as the value, and you will be having extra 2 more rows, 9, 8, which would be for RS. And here, since there is no value for X, it would be NaN. Okay, so suppose I am doing merging on index. Like I said, merging on index means I will be now merging based upon the index number and not on the column. So if I'm doing merging on index, see what happens here is I am having the complete data frame A as well as complete data frame B just next to each other. So I will not have key as ID. So that's why I'm having two columns, ID underscore X and ID underscore Y. Okay, so this is, in this case, if I have to do merging on index, I have to say left index and right index as true. Both are made as true. Now let's see this in the Python program in the Jupyter notebook. I have created a similar data frame here. Right? How did you create? Import the pandas, create a data frame A, and I've taken the same values. Right? This is our data frame A. So if I execute this, right, this is a data frame A with the ID column and val1 column. And I've created a data frame B. Again with the ID and val1, same name is there, but the values are 1298 and PQRS. Now let's first use pd.merge with only one argument, that is on. See, now I'm making on as ID. So basically what is on? It will tell the name of the key column. Basically ID would be the key column for doing the merging, right? So basically ID would be the key column for both of these data frames. So when you actually execute this, you understand, right? So the merging was done based only upon the ID. So what was common in these two tables? Only 1, 2. So that's the reason 1, 2 is printed and the values of X and values of Y are displayed. So here merging was done based only upon the ID. Suppose I try to do merging based upon the value 1. You can see that based upon value 1, if I do merging, there are no common values between both the data frames. Here it is ABCD, here it is PQRS, and that's why nothing is displayed here. Okay, now for on is equal to ID, that means now I'll be doing merging for the taking the column name ID as the key, and I'm doing left merging. That means what? I will be having entire data frame A, and in B only the common elements would be taken, right? So when I execute this, see, I have this is the entire data frame A, and only 1 2 was common. For that reason PQ is displayed, the other two are NaN. We saw this in the presentation just now. Now I'll just do the reverse. I will make how is equal to right. So when I see that, I will see entire data frame B, right? See, 1298 are the IDs of data frame B, and these are the values of data frame. And in data frame A, only the common elements are displayed. Now, if I do outer merging, so that means what? The entire data frame A and data frame B should be there. So that's the reason 2 more columns have come, right? So this is the entire data frame A, right? And this is a part of data frame B, and here is another part of data frame B. In data frame B, for the ID 98, the values of X are not there. So that's the reason NaN has come, not assigned. Now, if suppose I want to do merging based upon the index. Index, as I already told you, the above examples I did merging based upon the column names, where the column names were the key. If I do merging based upon the index, right? So then you have to specify left index and right index. Both of them, if I give as true, then what happens is I will be seeing the entire data frame A, and this is an entire data frame B, because I am considering the merging based upon the indexes 0 1 2 3. Now by default it will be false. So that's why, see, if I make both of them false, you can see nothing is displayed. Okay, so try these 2 examples of merging in your system. Try to write down as much as possible. Take various examples, write down the data frames of both, and then see how it works. Okay, thank you. And in the next class we will do concatenation operation.